Hello, this is Dr. Mears. Today we are going to be doing some geometric sequence examples. Notice I did write the general form of the geometric sequence up here. If you would please so do that, be great. Example 1, given u sub 1 equals 16 and u sub 6 equals 16,384, find the values of u sub 2, u sub 3, u sub 4, and u sub 5 such that the sequence is geometric. So now you will notice here that I also have labels. I like to label my numbers so I know what numbers I have and I know what numbers I need to find. So what numbers do I have? I have u sub 1 and I have u sub 6, and I need to find u sub 2, 3, 4, and 5. They also told me it was geometric, so there's going to be a common ratio or a common number that we're going to be multiplying by to get from one term to the next. We're going to have to find that common ratio, or R, here. And what I'm going to do is I'm actually going to do my work over here because I need some space. So this is u sub n. Now I have u sub 6. And so u sub 6 is going to equal u sub 1, which I have as well, times r raised to the n minus 1. Now, u sub 6, n is 6. So I can actually put 6 in place of the n here. Let's substitute our other numbers in. So since I have u sub 6, I'm going to replace it with 16384. Since I have u sub 1, I'm going to replace it with 16. And remember, this is being multiplied by r. I'm going to subtract 6 minus 1, 5. So all I did was I substituted the u sub 6. Instead of u sub 6, I put the number. I substituted u sub 1. Instead of u sub 1, I put the number. And I subtracted my 6 minus 1 to give 5. Now we need to solve. When we solve this, the first thing that we're going to have to do is we're going to have to divide by the 16. Divide by 16, divide by 16. And I brought down my r to the 5 and my equal sign. When I divide by 16, I am going to be getting, well, let's turn on our calculator. Let's actually do this together. Clear everything out. 16384 divided by 16. 1024. Now, here's the thing. This is r to the 5th. R to the 5th means we're multiplying a number 5 times itself to get 1024. So we have to solve for this. I'm going to show you the easiest way in the calculator to solve. In order to undo a root as a 5th root, we have to take the 5th root of the exponent of 5. Or I'm sorry, let me backtrack. In order to undo this exponent of 5, we have to take the 5th root. And now you're asking me, Mears, what the heck do you do in the calculator? How is this easy? All you have to remember is that you are going to put this number in parentheses, press the exponent button, and you're going to change this 5 into 1/5. This is how we take the root. The 5th root is really 1/5. If so, let's say, just a little side note here. So let's say we have r squared. So in order to undo r squared, we would take the square root. We usually don't write the 2 there. You're used to seeing it just as a square root. In order to undo, a cubed root, or r to the 3rd, we have to take the cube. In order to undo r to the 4th, we take the 4th root. In order to undo r to the 5th, we take the 5th root. This is the same thing as saying r raised to the 1/2. This is the same thing as saying r raised to the 1/3. This is the same thing as saying r raised to the 1/4. This is the same thing as saying r raised to the 1/5. Raising it to this fraction is the same thing as taking that root. 1/3 means a cubed root. 1/4, 4th root. 1/5, 5th root. That's what you have to remember, and that's how you do it in the calculator. So, to go back, we need to take the 5th root of 1024. So 1024 in parentheses, 1024. Press your exponent button, which is right above your division symbol. 1 division sign, that's the division sign, 5. That's what you need to do. And so we're going to come out with a ratio of 4. So if you take a fifth root of the exponent that's 5, they cross out and we're left with r. This is how you solve all these problems. So we now know that our common ratio is 4. So we have to multiply by 4 to get to the next number. So 16 times 4, 64 times 4, 256 times 4, 1024 times 4 is 4096 times 4. We get to 16,384. Okay, example number 2. In the geometric sequence, u sub 1 equals 5 and u sub 5 equals 405. The last term of the sequence is 295,245. Given that r, our ratio, is a positive number, find the number of terms. How many terms in this sequence? So let's say we have u sub 1, which is 5. We don't have u sub 2, there's the bell, u sub 3, u sub 4, u sub 5. We do have, that's 405, so we don't need these. However, the problem's not asking for us to find these. The problem is saying this is going to go on until 295, 245.
Those students that belong to the high school boys soccer, there's a bus up there waiting for you. I would suggest you get on that bus sooner than later. Your bus is waiting for you, and it is going to depart in about 30 seconds.
My apologies. That was saying that the bus for soccer is going to be departing. Of course, you can see I'm making this after school. Okay, so it starts at u sub 1. We have u sub 5, and it goes all the way to u sub we are not sure. It stops here. And so when we find out what this last number is, we're going to find out the term number, and that term number is going to tell us how many terms we have. All right, so Mears, what do we do? Same thing that we've done before. We're going to utilize our general term, u sub n equals u sub 1 times r to the n minus 1. But let's put in what we have. We have u sub 5. We have u sub 1. And because we have this 5, I'm going to put it where that n is. This n and this n should be the same, 5 and 5. Okay, let's put some numbers in. U sub 5, I'm going to put 405 equals u sub 1, I'm going to put 5. Let's see, r to the 5 minus 1, which is 4. Okay, so all I did is substitute my numbers in. Now, just like the problem that we did before, we are going to divide. 405 divided by 5 gives you 81 r to the 4th. Now, we have to undo this exponent of 4. So we have to take the 4th root. However, what do you have to remember in the calculator? All you remember is that we're going to put 81 and we're going to raise it to the 1 divided by 4. Here's your exponent button. And when you do that, we're going to come out with an r of 3. This is your calculator part. Okay. So we know that we're going to multiply by 3 to get to that next term. However, we're not going to go and do that all the way. There's an easier way. What do we have to do? We have to find what this n is. So this was step 1, finding r. Find r. This is step 2. We need to find n. So let's use our general term again. We don't know what u sub n is, but we do know what the actual number. We don't know what n is, but we do know what the u sub n is. So I'm going to substitute this number, new number in now, equals. So we know that it ends here. We just don't know that n. U sub 1, 5, times 3 is our r. We just found it, to the n minus 1. Okay. Again, let's divide by 5. So 2, 9, 5, 2, 4, 5 divided by 5 is going to give you 59049 equals 3 to the n minus 1. Here is the challenge. You can guess and check here. What do I mean by guess and check? We need to find n. What number can I put in for n that will give us 59049? You can guess and check. So you can say, all right, let's try this. 3, exponent, yep, there we go. 3 exponent button. And then you can see, let's try n is 8. Let's try that. So 8 minus 1. That gives us to 2187. That's long off. We need 59409. So let's try another one. 3 to the, let's try 11. So that doesn't work. N equals 11. Enter. Oh, look, I got it. That's cool. Okay, so I guessed and checked, and I found that n equals 11. That's guessing and checking. The other thing that you can do is you can break this down into, now you don't have to do this if you're a little confused, if you're like, nah, you know what, I'm just going to stick with guess and check. Stop the video here. Absolutely fine. However, mathematically, what we would do, and it's sort of like guess and check, is we would have to find common bases. So what number 3 to the 10th actually gives us 5049. And so when these are common bases, what we can do is we set the exponents equal to each other. So 10 equals n minus 1. And then it becomes a small algebra problem where n equals 11. And so how many terms are there? There are 11 terms. Now, again, this is sort of guess and check because you would have to find 3 to the 10, 59049. So you might want 3 to the 7, 3 to the 9. So, sorry, that's 2 to the 9, 3 to the 9. So you would have to, go and make this a common base. Again, you can use guess and check and put the number in. It's really easy with the calculator. Okay, this has been geometric sequence examples. We had a little soccer announcement. Call me over, try some practice problems, review the video. I hope it helped.